Hello everyone, welcome back to my YouTube channel Physics Unification. In this video, we can discuss the new chapter from the second PUC Science, Current Electricity. Here, we are going to study 3 marks and 5 marks derivation from this chapter.
Ohm's law. The electric current flowing through a conductor is proportional to the voltage, that is potential difference, across its ends, provided the temperature and other physical conditions remain constant. Here V is directly proportional to the value of I, or V is equals to R into I. Here V is the potential difference and I is the current through the conductor, and that R which gives the resistance of the conductor. Now, what do you mean by resistance? Resistance is the effective opposition offered by a conductor to the flow of charges through it, or it can be defined as it is the ratio of the potential difference across the ends of the conductor to the electric current, that is R is equals to V divided by I. SI unit of resistance is ohm.
Let us see the derivation of the relation E is equals to rho into J, or equivalent form of Ohm's law in vector form, that is J is equals to sigma into E. Resistance of a conductor depends on value of L, length of the conductor, area of the cross section, and value of rho. Rho is the resistivity. Here, resistivity of the material of a conductor is equal to the resistance of the conductor of the given material of unit length and unit cross-sectional area. Rho gives the value of R into A divided by L. Here, to derive the relation E is equals to rho into J, we have to use the relation R is equals to rho L divided by A in Ohm's law. Means what we will get by according to Ohm's law, V is equals to R into I. Just to substitute the value of R in the Ohm's law expression, then V equal to rho L divided by A into I. It becomes rho into L, I divided by A. Here I divided by A, which gives the value of current density J. Therefore, V becomes J into rho L. That taken it as equation 1. If electric field is the magnitude of uniform electric field which is applied in the conductor of length L, then value of V equal to E into L. Let us take it as equation 2. Thus from equation 1 and 2, left hand side is same. So just to compare equation 1 and 2 by right hand side, then what we will get, E is equals to E into L is equals to J rho L. Here L gets cancel each other, which gives the value of E equal to rho into J. In vector form, A equal to rho into J, or J equal to sigma into E, because 1 by rho, which gives the value of conductivity. Now the concept of drift velocity we have to know. The average velocity gained by the free electrons of a conductor in opposite direction to the externally applied electric field, which forms the drift velocity. Means here free electrons which gains the average velocity in opposition to the electric field what we have applied in that conductor, which gives the drift velocity. Here usually drift velocity order is of 10 raised to minus 4 meter per second. Now we can derive the derivation for drift velocity. Let us consider electric field E which is applied to a conductor. Then what happens? Electrons will be accelerated due to this field. Therefore, acceleration A which gives the minus E into capital E divided by m. Here minus E which gives the charge of that electron, m which gives the mass of that electron, and E which gives the electric field. If we considered ith electron and Ti be the time elapsed after the last collision, then what happens? Vi was its velocity immediately after the last collision. Then according to this relation, V is equals to U plus AT, we can write the expression as capital VI vector is equals to small vi vector plus A into Ti. Here capital Vi vector is equals to small vi vector. In place of A, what we have to substitute? Value of A. Minus E, capital E divided by m into Ti. Now average velocity becomes 0 immediately after any collision. Then Vi, small vi vector is equals to 0 and tau which gives the relaxation time. Here what do you mean by relaxation time? It's the average time between successive collision. Then Vi, capital Vi vector which changes to drift velocity Vd. In place of only Vi, we have to take the full complete average velocity. Vi average is equals to Vi, small vi average minus E into capital E divided by m into Ti average. Here Vi average which gives the value 0 because average velocity becomes 0 immediately after any collision. Then drift velocity Vd is equals to minus E into capital E divided by m into relaxation time tau. And this expression is also very important for 3 marks. Then what do you mean by mobility? It is defined as the magnitude of the drift velocity per unit electric field. We know the expression for drift velocity minus small e capital E divided by m into tau, and in denominator already which contains value of electric field E. Here E gets cancelled each other and which gives E into tau divided by m. Here magnitude of minus sign which gives the positive sign. Let us derive the expression for current I and conductivity sigma. Consider electric field is applied to a conductor towards left position. Due to this electric field, electrons are drifted towards right opposite to the electric field. Then we know drift velocity expression Vd is equals to minus E capital E divided by m into tau, and magnitude of that drift velocity which gives Vd magnitude is equals to magnitude of minus E tau divided by m into E. Magnitude of negative sign becomes positive. E tau divided by m into magnitude of E. Equation 1. Then due to drift, all electrons move to the right of the cross-sectional area A. Then distance delta x equals to value of Vd, drift velocity into delta t. How we wrote this expression? We know velocity is equals to distance divided by time. Therefore, distance can be written as velocity into time. If you consider there are n number of electrons, that is free electrons per unit volume in the conductor, then number of electrons present in the volume delta V becomes n into delta V. Delta V value is equals to n into delta x into area of the cross section A. Because delta V is the small volume and that small volume can be written as delta x small distance into area of the cross section A. Then it equals to n into value of delta x equals to Vd into delta t into value of area of cross section A. Therefore, total charge delta Q is equals to minus E that is charge of the free electrons into N Vd delta T into A, and it becomes delta Q is equals to minus N E A Vd into delta T. Just I rearranged that expression and let that one taken it as equation 2. But delta Q equals to the value of I into delta T. Equation 2 and equation 3 becomes I into delta T is equals to minus N E A Vd into delta T. If we consider charge positive E, means positive electron E, then it becomes I into delta T, which is equals to N into plus N, because here it is free electrons which having negative charge minus E. If we consider it as positive charge plus E, then it becomes plus N E A Vd into delta T. Comparing both the sides, here delta T and delta T gets cancel each other. Value of I equals to N into E into A into Vd, equation 4. Here I is equals to NEA. In place of Vd, what we have to substitute? Value of drift velocity, that is Vd is equals to E tau divided by m into E. Then I becomes NEA E tau divided by m into E. Here EE, it becomes E square. Then I is equals to N into E square tau into A divided by m into E. Magnitude of current density J can be written as I divided by A. Just substitute for value of I in the expression current density J is equals to I divided by A. Then what we will get? Current density J is equals to N E square tau A into E, magnitude of electric field E, divided by m divided by A, because value of I is this value and value of A is here in denominator. Then it becomes current density G is equals to N E square tau divided by m into E. Here value of A which gets cancel each other. So value of J is equals to sigma into E. Here value of sigma conductivity is equals to the N E square tau divided by m value, and value of rho. Rho is the reciprocal of conductivity sigma. Then resistivity is equals to 1 divided by conductivity. It becomes m divided by N E square tau. Up to here, this is for 5 marks derivation. Let us see some definitions of electric energy and power. The amount of energy dissipated as a heat in the conductor during the time interval delta t gives the electric energy. Here delta W is equals to I into V of delta t, and power can be defined it as the energy dissipated per unit time, that is P is equals to dW divided by dt, which is equals to the value of V into I. By Ohm's law, V is equals to I into R, and just by rearranging this expression, what we will get? I is equals to V divided by R. Then power expression becomes P is equals to I square R or P equals to the value of V square divided by R. This expression is very important for solving problems. P is equals to V into I. P is equals to I square into R, or P is equals to V square divided by R. Let us see the problematic part based on drift velocity. The number density of free electrons in a conductor estimated to be 8.5 into 10 to the power of 28 per meter cube. How long does an electron takes to drift from one end of a wire 3 meter long to its other end? The area of cross section of the copper wire is 2 into 10 to the power of minus 6 meter square, and it is carrying a current of 1.5 amps. Given current I equal to 1.5 amps, number of free electron is 8.5 into 10 to the power of 28 per meter cube. Charge of the electron we know 1.602 into 10 to the power of minus 19 electron. And area of the cross section they given that 2.0 into 10 to the power of minus 6 meter cube. Here what we have to find out, how long does an electron to takes drift from one end of the wire to other end means time we have to find out. How we have to find out the value of time? We know velocity is equals to distance divided by time. Here we have to take it as velocity in terms of drift velocity. First of all, before going to find out the value of t, we have to know the value of Vd. Then how we will find out the value of Vd? By the expression I is equals to nu d, current expression. Here we know the value of I, we know the value of n, we know the value of E, and we know the value of A. By this expression, what we have to find out? Value of Vd equal to I divided by NEA. Drift velocity Vd equal to I divided by NEA. 1.5 divided by N, 8.5 into 10 to the power of 28 into 1.602 into 10 to the power of minus 19 into A, 2 into 10 to the power of minus 6, which gives 1.5 all divided by 8.5 into 1.602 into 2, which gives the value 27.234 into 10 to the power of 28 into 10 to the power of minus 19 minus 6 is minus 25, which is equals to 1.5 divided by 27.234 is 0.0550 into 10 to the power of here 28 into 10 to the power of minus 25 is 10 to the power of plus 3. When it is comes to the numerator, it becomes minus 3. Now send this decimal point to the right side, then which gives 5.5 into 10 to the power of 1, 2. 2 digits they shifted means that point shifted means what we can take? Minus 2 into 10 to the power of minus 3. Therefore, Vd is equals to 5.5 into 10 to the power of minus 5 meter per second. How long means what we have to find out? Value of time. We know time equal to distance divided by velocity, that is drift velocity Vd. They already given that value of d equal to 3 meter divided by 5.5 into 10 to the power of minus 5. Then value of t is equals to 0.545. 3 divided by 5.5 is 0.545 into 10 to the power of plus 5. Therefore, value of t equal to, just take the decimal point to the right hand side, and what it will give? 5.4 into 10 to the power of minus 1 into 10 to the power of 5. which is equals to the value of t equal to 5.4 into 10 to the power of plus 4 second. This one is the time taken by that electron drift from one end of the wire to the other end, which completes the first part of the chapter current electricity. In the next video, we can discuss the concept of resistors, color code for resistors, and combination of resistors in series and in combination of resistors in parallel. If you have any doubts regarding these concepts, please drop a comment in a comment box. Stay tuned, like, share and subscribe my YouTube channel Physics Unification. Thank you.